Okay, we are looking at an example of stoichiometry in which we go from mole to mass. So in these types of stoichiometry problems, you're given an initial value in moles and you're asked to determine a corresponding value in mass with units of grams. So just so that it's very clear, I'm just going to write mole to mass. So this is a mole to mass problem. The way that you determine that is just look at what's given and what you're being asked to find. So our given here would be the moles of propane, (13.8 moles). And our unknown is going to be the mass of water. Alright, so similar to what we've seen before with the mole to mole stoichiometry, our first step to solving this problem of what mass of water is produced by the complete combustion of 13.8 moles of propane, our first step is going to be to write the balanced equation. So this is a complete combustion reaction of a hydrocarbon, and from the question we automatically should know exactly what's going to go into and out of this reaction. We know that combustion reactions are reactions involving oxygen, and we know already that if it's complete combustion, the products are going to be carbon dioxide and water. And then this is something that you also should be able to balance. I'm just going to balance it quickly now for the sake of this example. Alright, so in the completely balanced reaction equation, we know that we have 1 mole of propane reacting with 5 moles of oxygen to yield 3 moles of carbon dioxide and 4 moles of water. That is our molar ratio for this reaction. So what we are asked for here is the mass of water produced by the combustion of propane. So since this is a mole to mass problem, what we're first going to need to do to be able to determine the mass of the water, we need to find the moles of water first. We cannot go from mass to mass or moles to mass of a different substance. We must find moles first. So similar to the other examples, we're just going to set up our equivalent proportions to be able to determine the number of moles. So looking to my equation, I can see that there are 4 moles of H2O that are produced per every 1 mole of propane. So there is a 1:4 ratio of propane to water in this reaction. This here, I'm just going to circle it in blue. That's going to be basically our multiplier or our equivalent proportion that we're going to use to determine how many moles of water get produced in this reaction. So I can multiply this value in blue by 13.8 moles of propane, and this is going to give us a value in moles of water. We know this because we've set up the proportions such that the units of moles propane cancel out and leave you with just moles of water. And that's a way you can double check to make sure that you are on the right track in setting up your proportions. So when we multiply these values together, we are going to get a value of 55.2 moles of water that get produced by this reaction. So now that we have the number of moles, we want to find mass. And we know from before that moles equals mass over molar mass. To find the molar mass of hydrogen, we simply need to look at the periodic table. How much is the molar mass for 2 hydrogens and 1 oxygen on their own? and then all together. And for the sake of time, you would be expected to do this on your own, but we're going to say it's about 18.02 grams per mole. And then if we want to find the mass of the water, we simply need to rearrange this equation. So I just showed you a rearrangement there with the green. Rearrange the equation using algebra so that we get mass equals moles times molar mass. And then that's going to be equal to 55.2 moles times 18.02 grams per mole. The units of moles are going to cancel out, leaving us with a unit of only grams. That's how we'll know that we have done things correctly. So then when you multiply those two things together, you're going to get something equal to roughly 994.45 grams of H2O. And we can finish off with a therefore statement. Therefore, 994.45 grams of water are produced by the complete combustion of 13.8 moles of propane. So again, just to recap, I had identified there that it was a mole to mass problem by simply looking at what was given and what was unknown. The wording of stoichiometry problems really does not matter at all. You simply just need to determine what are the units that you're given and what are the units you're being asked to find. And then you'll be able to know if it's a mole to mass problem, a mass to mole problem, or a mass to mass problem. So we identified it was a mole to mass problem. Here we predicted the products of the reaction and we wrote out the reaction and we balanced it. And then here we set up an equivalent proportion using the mole ratios of the balanced equation to determine how many moles of water were produced. And then we use an equation we had previously seen relating moles to mass and molar mass, rearranged it using algebra to determine the mass of water that was produced. So that was an example of mole to mass. We will also be seeing examples of mass to mole problems and mass to mass problems.